So let's talk about MapReduce in some more depth here. MapReduce is one of the core pieces of Hadoop that's provided for you along with HDFS and Yarn. So understanding MapReduce is definitely important for understanding Hadoop. So what's the big deal about MapReduce? Well, it is the built-in means that Hadoop provides for distributing the processing of your data on your cluster. So its job is to divide all your data up into partitions that can be processed in parallel across your cluster. And it manages how that's done and how failure is handled and whatnot. So there are basically two things that MapReduce does. One is it maps data and it reduces data. Imagine that. So what does that mean? Well, mapping is basically transforming data. So basically, as data comes in one line at a time, your mapper is transforming that. It's extracting the information that it cares about as it comes in and organizing that into a structure that makes sense for you, for the problem that you're trying to solve. So for every input line, you receive one output from your mapper. That's just extracting and organizing the data that you care about. Now the reducer is what actually aggregates data together. So you can, when you map data, you associate your data with a certain key value, something that you care about that you want to aggregate on. And we'll look at some examples of this later on to make it a little bit more real. But basically, mappers are what transform your data and reducers are what aggregates your data. And these are functions that you provide in some programming language that do whatever you want. And by being creative with how you fit these things together, you can actually solve a very surprisingly large variety of analysis problems. MapReduce also provides a mechanism for handling failure. So anytime you're dealing with a cluster, you have to deal with the possibility of a particular node going bad, a computer locking up and whatnot. And MapReduce provides means of dealing with that we'll talk about in more depth. So let's make it real with an example. Let's say we're dealing with our MovieLens data set again, that data set that we have of users rating movies on 1 to 5 stars, and we had that 100,000 rating data set that we played with before. Let's say we want to take that data set and just figure out how many movies did each user rate in that data set. So let's say Bob is user ID 1 and he rated movies Ants, Forrest Gump, and Dumbo, whatever those movie IDs happen to be. And Sally is maybe user ID 2 and she rated The Lion King, Nemo, and Toy Story, whatever those movie IDs happen to be. So we want to figure out, okay, in the end, Bob rated 3 movies and Sally rated 3 movies. That's our objective here. So how do we make that into a MapReduce problem? Well, like we said, the first thing we need to do is transform the input data, the raw input data that we have in our data set, into a format that makes sense for us. So our mapper needs to take each line of input data, which is going to be an individual movie rating, and it will transform it into a key value pair. What does that mean? Well, the key is the thing that you want to aggregate on. So in this case, we want to aggregate the number of movies that each user watched. So our key would be the user ID in this example, right? And the value would be the movies that we're aggregating. So our mapper just needs to take each input line of our u.data file and convert that into key value pairs where the key is the user ID and the value is the movie that user rated. And a key point here, no pun intended, is that you may have the same key happening more than one time in this output, right? So if user ID 1, Bob, rated Star Wars, which is movie ID 50, well, later on in the data set, we might see Bob again, user ID 1 rating some other movie, and Bob might have rated another movie as well. That's okay. At this stage, we can have the same key can appear multiple times, and that's actually desirable. So making it real, let's take a look at a fabricated little subset of u.data here. And we'll go through this and see how it actually plays out. So let's say our u.data file contains this information in each line. Just a reminder, the columns correspond to user ID, movie ID, rating, and the timestamp that rating was made. So coming in, we have this metadata here, but what do we really care about? All we really care about are the user IDs and the movies, right? In fact, we don't even really care what specific movies are rated for that matter, but we'll set that aside for now. We don't care about the ratings at all. We're not trying to figure out any information about how these movies are rated or when they were rated. So this information can just be thrown out the window. Let's get rid of it. So our mapper function that we provide to MapReduce is going to transform each line of data into a given key value pair. So that mapper function that we write in some programming language will be called for each individual line of input data. So let's say this first line comes in. It's saying that user ID 196 rated movie 242 3 stars at this time. All we want to get out of that mapper for that call is a key value pair 196 242. All we care about is that user ID 196 rated a movie which happened to be 242. And we keep doing this for each individual line of input data. So this second line ends up getting transformed into user ID 186 watched movie 302. And then next line 196 watched movie 377. Again, we don't care about the ratings, we don't care about the timestamps, so we're throwing that away. And that's actually very important for optimization purposes because the less data you're pushing around your network on your cluster, the better. And you want to basically strip out all the information you can as early as you can in these sorts of processes. So again, the purpose of our mapper is just to extract and organize the data that we actually care about. So by the time we're done with our mapper function, the MapReduce framework just has this list of key value pairs that's floating around on the cluster somewhere. Okay, so at this stage, we just have a bunch of key value pairs of user rated this movie, another user rated this other movie, and so on and so forth. Now what happens next is kind of magic and automatic. So without writing a single line of code, MapReduce will do this next step for you automatically. It's called shuffle and sort. And this is where it actually aggregates together all the given values for each unique key for you. And furthermore, it sorts those keys, which might be handy in some search situations. So let's take a look at our example again. What happens from the shuffle and sort stage is it takes a look at all these individual key value pairs, and it aggregates together all the values seen for each unique key. Okay, so let's start with, for example, user ID 166. Now again, these key values get sorted as well, so we're starting with the smallest user ID. And it turns out that we only had one rating for user 166 in this particular set of data. That was 346 as the movie ID. So we end up just with a single key value, the user ID 166, and then we're given a list of all the values associated with that key. In this case, it's a list of length 1, which just contains the movie ID 346. Now the second value here, the second key, the second user 186 is more interesting. So we see here user 186 actually rated 3 movies, 302, 274, and 265. So what we get out of shuffle and sort is the fact that user ID 186 rated movies 302, 274, and 265. So we're associating this list of movies with the unique key 186. And we do the same thing for user ID 196, who watched movies 242 and 377, and user ID 244, who only watched one movie, movie ID 51. So you can see how this can be a little bit powerful, especially when you're thinking about it in terms of a massive data set that's running across an entire cluster. Remember, different mappers might be just processing different chunks of data. So all the ratings for user ID 186 might actually be coming from mappers on completely different computers. The power of MapReduce is that it will aggregate all those values together across the entire cluster for you and put them all together in one spot where you can process them together. And that's exactly what your reducer does. So given this output from shuffle and sort, basically the list of all values associated with a given key, your reducer is a bit of code that you provide that decides what to do with it to provide your output. So in this example, maybe we just receive a list of movies that's called movies, and we call some operator len on it to get the length of that list. So if this is all our reducer did, it would produce the output that we want. So for example, coming into our reducer, your reducer gets called once for each unique key, and it might be called, again, split up across an entire cluster. So you might have your reducer may be running in parallel across many computers, where each individual reducer is responsible for a given set of keys. But for each individual key, a reducer somewhere will be called once. So for example, we get called for user ID 166, and that receives a list of movies that just has one thing in it. So we end up with a output of 166. User ID 166 watched one movie. User ID 186 receives this list of 3 movie IDs, and if we just count up the number of movies, we end up with 186 watched 3 movies, and 196 watched 2 movies, and 244 watched 1 movie. So conceptually, that's how a MapReduce job would work to solve this particular problem. So let's put it all together, see it all in context. So again, we start with our raw input data. This is the contents of our u.data file from the MovieLens data set. Our mapper transforms each individual line of that into a key value pair. So in this case, the key will be the user ID, the value will be the movie ID for each individual rating. Shuffle and sort will put together all the given movies for each unique user and sort those users for us. So we end up with this from this example, where we just have a list of user IDs associated with the list of keys associated with each, the list of movie IDs associated with each user ID. And our reducer can then process each incoming list of values, each incoming list of movies, however it wants. We've chosen to just count up how many items are in the list, and we end up with a final result of the user ID and the number of movies that were rated by that user. Now, sit and stare at this if you need to. If you understand this slide, you understand MapReduce. Okay, it's really just that simple. So hit pause and stare at this until it sinks in, okay? Now, I do want to point out, too, that you might have noticed that the actual movies that were rated don't matter. All we care about are the counts. So, our mapper could conceivably have just output anything for the movie ID as long as it's some value. All we do is count them up in the end. So I could just as easily have had a mapper that just output the key value of the user ID and maybe the number 1 or, some constant value. It doesn't really matter what it is because the actual information of what those movie IDs were just gets discarded. So, sometimes there are little optimizations you can do like that as well. All right, so that's how MapReduce works conceptually. Let's talk in a little bit more depth about what's going on under the hood in our next lecture.